Welcome again to this week's lectures. Our new section is going to be on bipolar junction transistors, or BJTs as they're more commonly known. Before I go through our notes, there's firstly a couple of web articles that I'd like you to read, and these are really about bipolar transistors. They explain the basic functioning of the BJTs. So I've placed the links here and you'll be able to copy and paste from the slide itself, which is also on Canvas. The second article takes you through some basic fabrication development of the bipolar transistors. The third link is a video which explains more specifically about what the electrons and the holes are doing when the bipolar transistor is operating in its normal mode. And it shows whereabouts in the device the electrons and holes are moving from and to, and therefore where the current flows. It will also show that the electrons and holes dominate different paths through the device, but both types of charge carrier are important. And that's really why they're called bipolar devices, because there's two types of charge carriers bi, and they both contribute to the current. So the video also shows how the device switches on when a small voltage is applied to the first PN junction. There's two PN junctions in the device, and why a larger current flow results from the first small current flow. And that this is really why it enables the bipolar transistor to act as an amplifier. I'm then going to take you through the lecture notes that are on Canvas in the subsequent videos. And these notes will elaborate on the video analysis here. So I'd suggest watching this video listed first and then going through the lecture notes, which I will do with you on the videos. So they really complement each other, and I'll be explaining more about the device operation alongside the physical analysis, which will be introduced here on this video, so that you can see more clearly why the device operates as it does. I'll also be showing how to calculate the current flow in a bipolar transistor. And also, as we did for the PN diode, we'll go through the device characteristics for the BJT, so you can see the effect of applying a voltage to the device terminals on the output characteristics. And that is the typical resulting output current as a function of the applied voltages. Now, in fact, because these bipolar transistors have two important PN junctions, we're going to be looking at how and why the characteristics change as the voltage at each PN junction changes. Finally, there's a paper that you can read if you want, and this is about an advanced type of bipolar device that generates a current gain by using band engineering and straining the semiconductors. If you have time, I suggest you read this at the end of the whole section on bipolars, but do bear in mind that it's not compulsory, and I wouldn't expect you to follow all of the details. It's a very technical paper, but hopefully for those that are interested, it will show how combining semiconductors, in this case using compounds of silicon and germanium, opens up the possibility of higher performance devices. And this contrasts with the material that we're going to be covering here in stage 2, in which we tend to focus on the conventional methods for optimizing device performance. In other words, using suitable fabrication process, tailoring doping level in different N and P type regions, applying appropriate bias to the junctions, and optimizing the device dimensions. So that's what we're going to be learning about for the rest of this stage 2 course.